So why do we care about this? What are the impacts? Well, it's how do you do risk management? Fundamentally, there'll be for almost any warming in the tropics and subtropics where we have hunger and famine today, there'll be decreased agricultural productivity. For the temperate region, there'll actually be increased agricultural productivity, probably for the next 1 or 2 decades. And the reason is you get a longer thermal growing season. Spring arrives earlier, winter arrives later. But in the tropics, where we've got hunger and famine today, we're going to have decreased productivity for almost, we're already seeing it for any change. Therefore, we've got a real problem with food security. And of course, climate change can't be looked at independent of all other driving forces, and I'll talk about that on food security. Decreased water availability and water quality in arid and semi-arid areas, as well as increased floods and droughts in most regions, if not many regions. Well, therefore, real issues for water security. Adverse effects on ecological systems, especially coral reefs, but many others which I'll chat about. And therefore we could lose key ecosystem services that basically are the maintenance of human well-being and our economy. Increased incidence of vector-borne and water-borne diseases, heat stress mortality and malnutrition, therefore adverse effects on human health, and the effects on human settlements due to flooding, coastal erosion, sea level rise, therefore adverse effects on human security. So the challenge is, region by region, locality by locality, is to try and assess what the risks of climate change are in the context of all other pressures on food, on water, on biodiversity. So climate change must not be looked at in isolation of all other drivers. So on food security, we've been incredibly successful, haven't we, in the last 50 years. Total food production's gone up by about a factor of 2.6. Food production per person has gone up by about a factor of 1.4, except for a blip in food price over the last couple of years, and I've taken Y out of my presentation. Food prices at an all-time low, but 1 billion people still go to bed hungry every night, especially in sub-Saharan Africa, and it's nothing to do with food production. We can produce as much food as we want. Its institutional and policy environment is a disaster in most parts. Its rural development in developing countries is totally perverse trading policies in OECD countries. But not only have we not fed everybody, fundamentally it's leading to significant environmental degradation. The agricultural sector is leading to increases in greenhouse gas emissions. Roughly 15% of all greenhouse gas emissions come from the agricultural sector, about 15% come from our forestry sector, and 70% come from the way we produce and use energy. That's a rough number. We're losing biodiversity due to agricultural practices, and we're seeing land and water degradation. So at one level, it looks like we're doing a great job. At another level, we're doing a terrible job, in my opinion. So what's the challenge? Well, the demand for food will probably double in the next 25 to 50 years, especially in developing countries. We're also we need to increase the nutritional value of the food. We absolutely need sustained growth in the agricultural sector to feed the world, to enhance rural livelihoods, to stimulate economic growth, while at the same time meeting food safety standards. But the context is a challenge. Less labour, disease, rural to urban migration, less water, competition from other sectors, as well as human-induced climate change, less arable land, competition from, say, bioenergy, in addition to roads and cities, high energy prices leading to high fertiliser prices, high cost of mechanisation, distorted trade policies, land policy conflict, and the environmental issues of loss of biodiversity at the genetic species and ecosystem level, increased level of regional air quality, acid deposition, tropospheric ozone, and of course a changing climate. So when one thinks about food security, one has to look at all of these issues in which climate change is a major factor, but it's not the only factor. If we don't think of the multifunctionality of agriculture, that is placing agriculture in a social, economic and environmental context, we will not understand how to look at the risk of climate change on agricultural production. IFPRI, International Food Policy Research Institute, one of the CGIAR centres here in Washington, D.C., down on K Street, CGIAR being the consultative group of international agricultural research, they've actually done a projection for irrigated rice in the year 2050. All of these slides can be had by anybody. I'll leave them on the computer and anyone can have them to look at them at leisure. But one's looked effectively at areas lost or to areas gained, where production has gone down, the red and the yellow, to where production's gone up, the blue. You can't absorb it all in a quick slide, but overall the view was it would lead to climate change, and I'll show you another slide in a minute, would lead with this particular climate scenario from the National Centre of Atmospheric Research, 27% loss of global production for irrigated rice. They did rain-fed rice, and they felt their projection was a 13% loss. So they've looked at rice both rain-fed and irrigated. If you then looked effectively by region, South Asia, East Asia, other parts of the world, the green is the production today. The red is the projected production in the year 2050 without climate change, and the yellow is the projected production with climate change. And what you can see, a modest increase from today to 2050, but some of it, more than half of the gain, is lost due to climate change. Here it's an even bigger loss, where they felt in East Asia and the Pacific, the production in 2050 for rice will actually be less than the production today. They also looked at wheat production, same thing, production today, production in 2050, potentially a factor of 2 increase without climate change, almost no increase with climate change. And you see this particularly in South Asia, Europe and Central Asia. They did it for maize production, which does not show the same negative effect. If anything, there's a slight improvement here. Other places, not much of a change at all. So one looks to see what are the implications of climate change on various key cereals, and in general, other than maize, is extremely negative, which says they've looked at calorific intake, or availability, I should say. And as you can see in South Asia, if anything, there'll be less calorific availability in 2050 today. The same in East Asia, same in Europe, etc. A fairly miserable set of projections, as you can tell. One's looked at the implications for food price. Today's food price projected for 2050 without climate change, projected for 2050 with climate change. And you can see for rice in particular, it more than doubles. For wheat, it more than doubles, etc. So when one's trying to think about climate change and the impact on food security, and therefore on nutrition, a main part of human health, these sort of projections are fairly dire. Water security. Clearly, water scarcity is growing. By 2025, probably half the world's population will live in areas that are projected to be water stressed, in fact severely. Water quality declining in many parts of the world. 70% of all fresh water today is used for irrigation. It's not sustainable. In fact, 15 to 35% of all irrigation today is already unsustainable. We've lost a lot of the wetlands, a different issue. Cost recovery in the water sector is abysmally low. We're not putting the right value on water, and when you've got a scarce resource and you don't value it and you don't have cost recovery, it's just wasted. And of course, the key issue is human-induced climate change is a major threat. So we've already got a problem with water. Per capita demand is going to be going up, more demand from the private sector, from industry, and therefore a real challenge for how do you allocate the water resources between industry, the home, and the agricultural sector. And this literally sort of shows the map without climate change of various areas of the world that are really going to be far more stressed for water in 2025. If you superimpose upon that the climate map, and I dropped the slide out in my presentation, one again has got a fairly severe effect, especially in most of the major food bowls of the world. So water is a key issue. Biodiversity, in its own way, a major issue. What we did in the Millennium Ecosystem Assessment is looked at a series of ecological systems, 3 forested systems, 4 dryland systems, and a series of water systems, and then islands, mountains, and polar. We asked what were the 5 major drivers of loss of biodiversity. The habitat change, a conversion of a forest into an agricultural system, for example. Climate change, invasive species, both purposeful and accidental. Overexploitation, we're seeing that in the world's ocean today. 25 to 30% of the world's oceans are overfished. 50% are absolutely maximum of sustainable catch. And therefore, there's only about 25% have any potential of additional catch. And in pollution, nitrogen, phosphorus, sulfur. The colour in the box says what happened over the last 100 years. So a red box, like these, meant that habitat change was a major driver of change of tropical forests, a major driver of change of temperate grasslands. So red shows a major change over the last 100 years. If it's yellow, it means it was not a major driver of change over the last 100 years. And you see for most of the ecosystems, climate change was not a major driver. It was a moderately important driver in the polar region. The arrow says what do we project will happen in the next 50 years. And it's a vertical arrow. We would say it would be a very rapid increase in the importance of that driver for that ecosystem. And what you can see for climate change, as well as actually pollution, that we would actually expect climate change to be a major driver for change for literally every ecosystem that we're looking at. And therefore, if we don't get to grips with climate change, it may be the dominant change for ecosystems over the next 100 years. So again, when one's doing a risk analysis and say, what's important to climate change, you have to put it in context of all other changes to see the relative importance of climate change compared to habitat change, overexploitation, pollution, etc.